Assalamualaikum and hi everyone. Welcome to our video presentation for session 256 Basic Analytical Chemistry. Today our group will be presenting our experiment titled Separation of ink using paper chromatography. So without further ado, let's get started. Assalamualaikum and hi everyone. Today our group will be presenting our experiment called Separation of ink using paper chromatography for session 256. So, paper chromatography is a simple technique used to separate a mixture into its individual components. It involves two phases, the stationary phase, which is the chromatography paper, and the mobile phase, which is the solvent. When the solvent travels out the paper by capillary reaction, it carries the pigment along with it. Since different pigments have different solubility and affinity towards the paper, they separate at different points. We then use the RF value, which is the distance traveled by the pigment divided by distance traveled by the solvent, to identify each pigment. So why we choose ink? We choose ink because even though it looks like one color, it actually contains many different pigments. So let's get started.
Now I will explain the theory behind paper chromatography. Paper chromatography is a separation technique used to separate mixture into its individual components based on how they move through a medium. In this experiment, the medium is the chromatography paper, which acts as the stationary phase, while the solvent acts as the mobile phase. The separation occurs because different dyes have different physical properties. First, they have different solubilities in the solvent. Some dyes dissolve more easily in the solvent, while others dissolve less. Second, the dyes have different attractions to the paper. Some dyes are strongly attracted to the paper, whereas others are more strongly attracted to the solvent. When the bottom of the paper is placed in the solvent rises upwards through the paper by capillary reaction. As the solvent moves upward, it carries the dyes molecules with it. Dyes that are soluble in the solvent and have a weaker attraction to the paper will travel farther up the paper. On the other hand, dyes that are less soluble or more strongly attracted to the paper will move more slowly and travel a shorter distance. Because each dye has different solubility and attraction, they move at different rates, causing the original mixture to separate into distinct color spots. This separation allows us to identify the different components present in the mixture. Therefore, paper chromatography works based on the difference in solubility and attraction between the components, which cause them to travel different distances and separate from one another.
Now, let's move on to the procedure for this experiment. First, we need to cut the chromatography paper into a strip of suitable size. Second, draw a baseline about 3 cm from the bottom edge of the paper. Next, mark the spot where the sample will be placed on the baseline and label the color for each spot. Finally, using a ball pen, place a small drop of the ink onto the marked spots. Moving on to the next part of the procedure. Mix about 50 ml of 99% acetone with 9 ml of distilled water in a 100 ml beaker. Stir the mixture until it is completely dissolved and then pour it into a 2000 beaker. Hang the chromatography paper using a clamp and retort stand and slowly immerse it into the solvent. Next, make sure the paper does not touch the walls of the beaker and ensure that the solvent level stays well below the baseline. Allow the solvent to rise until it reaches about half the distance of the paper and then immediately mark the solvent front. And lastly, let the paper dry for 5 to 10 minutes. When it's dry, draw a clear line across the solvent front that has been marked.
Now let's dive towards our observation towards this experiment. This picture shows the chromatography result for black, blue, red and orange ballpoint pen inks using an acetone water solvent system. And during the experiment, the solvent moved upward through the chromatography paper and carried the ink pigments along with it. Different pigments travel different distances depending on their solubility in the solvent and their attraction towards the paper. From the chromatogram, we observe that black ink separated into blue and yellow pigments. Red and orange inks also separated into multiple pigments, showing that these inks are mixtures of several dyes rather than just one pure colors. Now we are going to show the calculations of the RF values for each separated pigment. So the RF value was calculated by dividing the distance traveled by the solute divided by the distance traveled by the solvent front, which was 4.8 centimeters. So first, the blue pigment from the black ink was calculated to be 0.146, while the yellow pigment from black ink was 0.438. The blue ink was calculated to be 0.250. The pink pigment from the red ink was 0.625, and the yellow pigment from the red ink is 0.917. The red pigment from the orange ink is 0.396, and the yellow pigment from the orange ink, we have calculated it to be the 0.938. And we can see that the highest RF value was shown by the yellow pigment from orange ink, indicating that it was the most soluble in the solvent and had the weakest attraction towards the chromatography paper. In contrast, the lowest RF value was shown by the blue pigment from black ink, meaning it was less soluble in the solvent and more strongly attracted to the stationary phase.
So, to conclude, our experiment was a success. We successfully separated the pigment in different ballpoint pen ink using paper chromatography with an acetone water solvent system. This separation happened because different pigments have different solubility in the solvent and different affinities towards the paper. This gives us different RF value for each pigment, the lowest being 0.146 for the blue pigment in black ink and the highest being 0.938 for the yellow pigment in orange ink. We also found that black, red, and orange ink each contain more than one pigment, proving that they are all mixtures. Overall, this experiment proved that paper chromatography is a simple but effective technique for separating and identifying components in a mixture. Thank you.
Begging, baby, please don't go. I just had to let you know you're